How good filament dryer is AMS HT compared to other dedicated dryers? Hello, welcome to my tech farm. A few weeks ago I tested the drying capabilities of AMS 2 Pro, and in this video I want to do the same thing but with the AMS HT. This box is sent to me by Bambu Lab for exactly this purpose, to test its drying capabilities, but accept that I got this product for free. This is not a sponsored video by Bambu Lab, but this video and actually the whole channel is sponsored by Polymaker. Let's see a few specifications from the website. The maximal temperature is 85 degrees Celsius with the maximal power of 150 watts. And very important property of this unit too, same like with the AMS 2 Pro, that it can rotate the spool during the drying. It has an active air vent, airtight filament storage, so this means that after the drying we can store the filament in and it will be protected from the environment. Ceramic inlets, so we can use some carbon fiber and similar abrasive filaments too. Bypass outlet for the TPU. In future, the AMS HT I want to use with my Bambu Lab H2D printer, but only for this video. Currently it is connected to P2S because this is smaller printer and I can easily move it here to our living room for recording this video. The installation is very simple. There is a communication cable which has to be connected to the AMS 2 Pro, and since the HT is the second unit, which I also want to use for the drying, it requires some external AC power too. And when everything is plugged, we can turn on the printer and to remind us to do something. In my case, it was a firmware update and it was ready for the use. I already mentioned that this is not a full review of this unit. I will just show you a few seconds of the unboxing, but in this video I only want to test its drying capabilities. And for this I will do my regular sponge drying test, and during this 1 hour I will measure the temperature and relative humidity, and later I am analyzing the data. I'm not sure do I have to mention why do you need a filament dryer. With the AMS 2 Pro with the maximum of 65 degrees Celsius, it is enough for PLA, PETG, TPU, but if you want to dry nylon, PPA, PPS and similar filaments, polycarbonate, in that case drying on 65 degrees Celsius is not enough. The nylon would require maybe even 1 week or even more. I tested this. So for this 85 degrees Celsius is very welcome, and with this we can significantly shorten that drying time. This will be the position of the sponge approximately in the center of the spool, and I use that bypass hole to insert the cables for the sensor, and it will be approximately 50 millimeters above the input hot air. The data I'm collecting with Arduino Uno, and here I can see the temporary temperature and relative humidity, but every 10 seconds I will collect the data on the laptop. I have new method connecting the wires. Without this jumper wires, this can go even through smaller holes, and I'm using this for the connection. Weight of the anti-sponge 0.568. Adding 2 milliliters of water, but I will measure the weight, it's more accurate. 2.558. $85 degrees Celsius. No need to rotate the spool. Start. It looks like it can reach 85 degrees Celsius very quickly according to its own sensor, and a few seconds ago I heard that it opened the ventilation valves. Only 6 minutes of the drying, and relative humidity is 29%, falls down, so the ventilation valves works nice. According to my sensor, 69 degrees Celsius and 26% relative humidity, but of course the sensor is on different location. Later I will try to measure exactly the input hot air temperature. After 20 minutes, relative humidity 16% according to its own sensor, and very similar according to mine, but the temperature is still 75. Time for the half hour measuring. Oh, very dry. 0.542. Looks like the peak temperature on this position is 76 degrees Celsius approximately. 50 more minutes, but relative humidity is very low, so that ventilation valve works nice. And it is one of the quietest dryers, and this will be the main reason why I will replace all my dryers with this one. Let's measure it. Even my laptop makes some noise, but from half-meter distance, 35-36 decibels. But for the feeling here in live, it is very quiet. View from the thermal camera. This is the front right side. 56 degrees Celsius, so it should be safe for the touch. Yes. And this is the back side. And here we can see that the input hot air is on the back side and the sensor is approximately here only from inside. And time for the last measuring. .537. Drier than before the test, because it had some moisture in it from the environment. But the peak temperature was 77 degrees Celsius, which this would be some static dryer, which rely only on the air circulation. I would say that this is not enough, because the drying would be very uneven. But this unit can rotate the spool during the drying, so in this case the temperature of the input hot air is more important, and let's measure it. I hope it's visible now that I move it exactly above the input hot air. Let's follow this temperature. It's turning on and off the heater, but as you can see it is approximately 84 degrees Celsius, and one more time the position of the sensor exactly above the hot air. Turning it off, and I will collect some cooling data too. Let's analyze the measured data. This is the time in minutes, and here we can see the temperature and relative humidity. Here it was open for 30-minute measuring, here for 1 hour measuring, and at this point I moved the sensor to be exactly above the input hot air, and here it was turned off, and this is some cooling data. We can see these small waves. Here they are more visible. This is turning on and off the heater when it reached the set temperature according to its own sensor. And we can see the maximum was 77 degrees Celsius when the sensor was 50 millimeters above the input hot air. And if this would be some filament dryer, which only rely on the circulating of the air, I would say that this is not enough. But very important property of this unit that it can rotate the spool. In this case, the temperature of the input hot air is more important, and that was correct, very close to that set temperature. Now let's talk about relative humidity. Here I could record that the ventilation valve was opened, and we can clearly see the effect of it. It works great. Unlike with the AMS 2 Pro, we have the same size valve, but there for 4 spool volume, and here it is only 1 spool volume, and it works fantastic. Here it was open for 30-minute measuring. I let out some minimal amount of the moisture. Same thing here, hardly noticeable on 60 minutes. This was moving on the sensor, and this is some cooling data. Result of the sponge drying test. Even after 30 minutes, it removed all the water from the sponge, actually even more because it had some moisture from the environment before the test. I mean, this test makes sense only if the maximum was 50 or 70 when I started. Now only collecting the data of the relative humidity and temperature is useful from this experiment. Final thoughts. I really like AMS HT as a filament dryer. This unit was sent to me by Bambu Lab for this review video, but sometimes I need to dry more than one filament at once, and the drying process is quite slow. I bought another one. And why do I like these units? Well, 85 degrees Celsius max temperature, it can rotate the spool during the drying, and it is quiet, very important property for me, and this ventilation hose on the back side works great. Unlike on the AMS 2 Pro, we have the same size ventilation valve on the back side for the 4 spool volume, and it is quite covered. And I could measure that it could work a little bit better, maybe with the 2 valves or something like that, but with the AMS HT it could really reduce that relative humidity very quickly. This was my experience with these units. If you have some other, feel us down in the comment section. Huge thanks to the Polymaker for sponsoring my channel and to all my Patreon supporters. And as always, happy drying and printing.